Hi, this is the first part of my video lecture on vectors, which is a part of the syllabus of class 11 physics. We will start this lecture with the classification of physical quantities into three categories, namely vectors, scalars, and tensor quantities. After defining them, we will talk about properties of vector, where we will learn what is magnitude of a vector, direction of a vector, what is tail and head of a vector, what are parallel or collinear vectors, what is equality of vector, that is when two or more vectors are said to be equal. We will talk about commutative and distributive properties of vectors. We will learn unit vectors, null vectors, etc. Thereafter, we will learn how to add and subtract two or more vectors, where we will basically talk about two laws. The first one is triangle law of vector addition, and the second one is parallelogram law of vector addition. We will also see that these two laws are equivalent to each other. That is, they are not independent things. They are just two different ways of stating the same fact. Thereafter, we will learn what is component or resolution of a vector. Finally, we will solve some numerical problems from the book H.C. Verma to solidify our concept. So this is Anand. You are watching 23.5 degrees. Let's start. A large number of physical quantities exist around us, and we divide them into three broad categories. Number 1 is vector, number 2 is tensor, and number 3 is scalar. Vector quantity have magnitude as well as a direction. That means to describe a vector quantity, we need to have its magnitude as well as its direction. An important point about vector quantity is that they can be added according to triangle rule. Few examples are displacement, velocity, acceleration, force, electric field, magnetic field, etc. All these are categorized under vector quantities because each of them, apart from having a magnitude, has a direction as well. Now, scalar quantities only have a magnitude but no direction. Adding or subtracting scalar quantity is very easy, and we can do so using the ordinary rules of algebra. Just like, let's take mass as a scalar quantity, then 2 kg plus 3 kg is equals to 5 kg. See how easy it is to add two or more scalar quantity. Similarly, subtraction is 1 kg. So, the addition or subtraction of scalar quantity is very easy and can be done by the ordinary rules of algebra. Few more examples of scalar quantities are volume, time, energy, electric potential, etc. The third category of physical quantities is tensor. They have a magnitude as well as a direction. Then what is the difference between a tensor quantity and a vector quantity? The only difference between them is that while a vector quantity can be added according to the triangle rule, a tensor quantity cannot be added using triangle rule. An example of tensor quantity is current. This is not the end of our discussion. Now we will take each of them to understand the difference between vector, tensor and scalar one by one. Let's start with scalar quantities, which is the least complex out of the three. Scalar quantities are those quantities which only have a magnitude, right? They only have a magnitude. They have no direction. If you want to describe a scalar quantity, what you have to mention? Its magnitude only. Few examples are mass, time, volume, pressure, area, etc. Let's take mass to understand the concept. When you go to a shopkeeper and ask him to give you 2 kg of sugar, the shopkeeper exactly gets the idea of what you want and he gives you this much of sugar. You never go to a shopkeeper and say something like, give me 2 kg of sugar in the east direction, or give me 2 kg of sugar in the north direction, or in the northeast direction, or in any possible direction. You never say something like this, because if you do so, it would make no sense. It would be ridiculous, right? Why? Because you are talking about mass which only has a magnitude. It has no direction. Similarly, let's take time. When we say that 30 minutes of time has been passed, it's a complete information about time. Okay? It's a complete statement in itself. Because the passage of time does not possess any direction. It is not that this 30 minute of time has passed in some direction, say east or south, or if you take it as the positive y-axis and you take it this as the positive x-axis, then it is not that this 30 minute of time has passed at 45 degree from the positive x-axis, right? Time, being a scalar quantity, has no direction. It only possesses a magnitude. Clear? Let's talk about another type of physical quantity, which is vectors. We know that a vector quantity has two properties. First is magnitude and second is direction. So, to describe a vector quantity completely, we need to mention both its magnitude as well as its direction. There are several examples of vector quantities like displacement, velocity, acceleration, then it comes force, electric field, etc. There are many more. Okay. So to describe a vector quantity, you need to mention its magnitude as well as its direction. Let's say you started from a point A to reach a point B following some random path like this. If I ask you, what is your displacement? Your answer would be the length of this line, this dotted line, is my displacement. But it's not true. Displacement is a vector quantity. And you are only talking, when you say that the length of this line segment AB is your displacement, you are only talking about the magnitude of your displacement. Okay? So let's say the length of this line segment is 500 meters. Then the magnitude of your displacement is 500 meter, but displacement, being a vector quantity, possesses a direction as well. Since you are starting from point A to reach another point B, so the direction of your displacement is from A to B. Now it is a complete statement. AB, vector AB is your displacement vector, the length of which is 500 meter, which is known as magnitude of vector AB. Magnitude of a vector is equals to the distance between its tail and head. The starting point is known as the tail and the end point is known as the head. So the magnitude of your vector is 500 meter and it is directed along the line AB from A towards B. While returning from the point B to the point A, the magnitude of your displacement is again the length of the line segment AB, which is 500 meters, right? Because the length of the line segment is same, whether it is from A to B or from B to A. But this time in your return journey, the displacement has a different direction, which is exactly opposite to the original direction. Earlier, it was from A to B, but while returning back, the direction of your displacement vector is from B to A, and we will write it something like vector BA. Remember, the arrow only shows that we are talking about a vector quantity. Let's talk about properties of vectors, and to understand it, let's come back to scalars again. To understand the concept, we are taking the example of mass, which is a scalar quantity. If I ask you what is 2 kg plus 3 kg, your answer would be 5 kg. If I ask you what is 3 kg plus 2 kg, your answer would again be 5 kg. So we can clearly see that no matter whether you are writing it as 2 plus 3 or 3 plus 2, both would get you the same result. So when it comes to addition of scalar quantities, the order in which you are adding things together does not matter. Even if we take the example of more than 2 scalar quantities, let's say 2 kg plus 3 kg plus 5 kg, no matter whether you are adding 5 and 3 first and then adding the result with 2, or you are adding 2 and 3 first and then adding your result with 5, both would get you the same result, which is 10 kilograms. We can clearly see here that in case of scalars, the order in which you are adding things together does not matter. Exactly the same property is followed by vectors also. Two vectors, vector A plus vector B, when added together would give you the same result when vector B and vector A are added together. So vector A plus vector B is equals to vector B plus vector A. This property has a special name. We call it commutative property of vector addition, or simply commutative law of vector addition. Okay, so the order of addition does not matter in case of vectors too, just like we seen in case of scalars. Similarly, even if we take more than two vectors, let's say vector A plus vector B plus vector C, whether we are adding these two vectors first and then adding the result with vector C, or we are adding the first vector with the result of the addition of the last two vectors, both would get you the same result. Okay, this property also has a special name. We call it associative law of addition of vectors. Associative law But how to add two or more vectors? This is your concern. We are going to study triangle law of vector addition and parallelogram law of vector addition very soon. Remember, I have not mentioned the properties of vector multiplication. For that, I have dedicated a separate video. You can watch it. Here, we will only talk about vector addition and vector subtraction. If I ask you what are the properties associated with a vector, your answer would be there are two properties. First is magnitude, which is nothing but the length of the arrow representing the vector. In this case, this is the length of the arrow from here to here, which is the magnitude. And the second property is direction, and the direction is shown by this arrowhead. Since a vector is described by its magnitude and direction, if I am not changing any of these two properties of a vector, I am not changing the original vector too. So if I simply pick this vector and without changing its magnitude or direction, I put it somewhere else in the universe, I am not making any change, right? Because I am neither changing the magnitude nor its direction. So suppose I pick this vector and put it somewhere, keeping the direction and magnitude of this original vector same, then I am not making any change. So this vector, if this is vector A and this is vector B, then vector A is equals to vector B. Why? Because both the vectors have the same length, that is, both the vectors have the same magnitude, as well as the direction. The direction of both vectors are exactly same. Two vectors are equal if both of them have the same direction as well as the same magnitude. That means two vectors are equal if the length of the arrow representing them is equal and their direction is also same. So this vector seems equals to this vector, right? The length of the arrow seems equal and the direction is also same. Similarly, this vector and this vector are equal. Vector A is equals to vector B. Why? Because both have the same magnitude. The length of the arrow representing this vector is equals to the length of the arrow representing this vector. That is, the magnitude of vector B is equals to the magnitude of vector A, as well as the direction of both the vectors are same. So we will say vector A is equals to vector B. Now we have another property of vector. If we are not changing the original direction and magnitude, we are making no change. So a vector can be shifted anywhere in the universe without changing its magnitude and direction. Okay, you can simply pick this vector and put it anywhere else and you are making no change, because you are neither changing the magnitude nor the direction. If you change either the magnitude or direction, then the two vectors are not equal. So if, say, this is vector AB and you pick it from here and put it somewhere else like this, now even if the magnitude is same, that is, the length of the arrow representing the vector is same, okay, the direction has changed. So we will say that vector A, let's say this is vector A and this is vector B, then vector A is not equals to vector B. Let's talk about collinear or parallel vectors. Remember, when it comes to vectors, the word collinear and the word parallel has the same meaning. That means it makes no difference whether you call two vectors as collinear vectors or two vectors as parallel vectors. You are conveying the same meaning. Both the statement has the same meaning. When we will call two vectors as collinear or parallel vectors? It's simple. Two vectors are said to be collinear or parallel if they either have the same direction or exactly opposite direction. It's as simple as this. So vector AB is parallel to vector CD is parallel to vector EF because all of them have either the same direction or exactly opposite direction. Similarly, this vector GH is also parallel to the above three vectors. Why? Because all of them either have the same direction or exactly opposite direction. Similarly, vector IJ, I am talking about this vector IJ is parallel to vector KL. Remember, magnitude does not matter for two vectors to be collinear or parallel, only their direction matters. So since vector KL and vector IJ have exactly opposite direction, so we can say that these two vectors are collinear or parallel. Similarly, vector MN is also collinear with vector IJ and vector KL. Can you tell me if vector MN and vector OP are parallel with each other or not? Of course not. They are not parallel because their directions are neither same nor exactly opposite to each other. Similarly, vector QR is not parallel with any of the above vectors because its direction is different from all the given vectors, right? Now, why we call vector AB and vector GH collinear even they are not lying on the same line? Remember the property of vector that we talked about a while ago, that you can pick a vector from its original position and shift it anywhere in the universe without changing its magnitude and direction. So these two vectors, say this vector and this vector, are parallel or collinear even they are not lying on the same line, because let's say it is AB vector and let's say it is CD vector, then you can simply pick any one of these vectors, say CD vector, and put it with somewhere here without changing its original direction and magnitude, and in that case these two vectors will lie along the same line, right? So for this reason, two vectors are collinear or parallel even if they are not lying on the same line, because the property of vectors says that you can pick a vector from its original position and shift anywhere in the universe without changing its magnitude and direction. Let's learn how to add and subtract two or more vectors. To do this, we have two laws, we have two kind of tools. The first one is triangle law, which sometimes is also referred as the polygon law. And the second one is parallelogram law. In fact, both these laws are equivalent to each other. That means that they are just two different ways of stating the same thing. They are not independent laws. Clear? Now, what the triangle law states, if two vectors are represented by the sides of a triangle both in magnitude and direction taken in order, the resultant sum of the vectors is given by closing the third side of the triangle taken in reverse order both in magnitude and direction. That means, let's say we want to add two vectors. The first one vector is vector AB and the second vector is, let's say it is vector BC. Then the result of the addition of these two vectors, which we also call as the resultant of these two vectors, would be represented by the third side of this triangle. Okay, third side of this triangle, and the direction of the resultant would be in the opposite order, in the reverse order. We were going from A to B and then from B to C, so the direction of the resultant would be not from C to A but from A to C in the reverse order. So vector AB plus vector BC is equals to vector AC. This is what the triangle law of vector addition states. If two vectors are represented by the sides of a triangle, here vector AB and vector BC are represented by the sides of a triangle taken in order, that means we are going first from point A to point B and then from point B to point C. In other words, you can say the tail, the head of one vector, okay, B is the head of vector AB, is coincident with the tail of the other vector. That is, the tail of vector BC is also the same point B. Then the resultant of the addition of vector AB and vector BC would be another vector which would complete this triangle, that is vector AC. The direction would be taken in the reverse order. That means we were going from A to B and then from B to C. Then the resultant of these two vectors would be from A to C in the reverse order, not from C to A. It would be from A to C. Clear? In fact, you can add any number of vectors using this law. That is why we also call it polygon law. Let's see how. Let me erase it first. Okay, let's say there are several vectors. Let's say the first vector is AB. Remember, the head of each vector should be coincident with the tail of other vector. This is a very important condition for triangle to apply the triangle law. Okay, so let's say vector BC is another vector. There is another vector which is vector CD. Okay, and there is another vector which is DF. If I ask you what would be the result of the addition of vector AB, vector BC, vector CD and vector DF, we will apply triangle law or the polygon law. Why we can apply polygon law? Because all these vectors are representing the side of a polygon and all these vectors are taken in order. That means the head of each vector is coincident with the tail of other vector. Vector AB, then BC, we are going in an order. It is not like vector AB, then vector CB. It is like vector A, B, then BC, then CD, then DF. The resultant would be shown by this side, which would complete this polygon. And why this would be the resultant vector? Okay, this would be the resultant vector. Why we have taken the direction from A to F, not from F to A? Because we are going first from A to B, then from B to C, then from C to D, then D to F. So the direction of the resultant would be from A to F, which is in the opposite order. Coming to parallelogram law of addition, it states that if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. So what does it mean? It simply means that, let's say you want to add two vectors. The first one is vector A and the second one is vector B. Your job is to add them together. So what you would do to apply parallelogram law here? First, we have to make the tail of both the vectors coincident. So we will pick any of these two vectors. Let's say we will pick vector B and put it here in a way that the tail, this point, coincide with the tail of vector A. The tail of vector B coincides with the tail of vector A. So it would look something like this if we do that. Vector A and vector B. Once we have made their tail coincident, we can apply parallelogram law. To find what is vector A plus vector B, we would simply complete this parallelogram by drawing parallel sides. Once we completed the parallelogram, the resultant of vector A and vector B, that is vector A plus vector B, would be represented by the diagonal of this parallelogram passing through the common tail of both the vectors. Okay, so this would be the direction and magnitude of the resultant vector of vector A and vector B. There are two formulas associated with the parallelogram law of addition of vectors. Let's say we are adding two vectors. The first vector is vector A and the second vector is vector B. This is the second vector. So what we will do? We will first make sure that their tails coincide. We know that the tail of vector A and vector B here is coinciding at this point. So now we can apply the parallelogram law. Let's complete the parallelogram, the imaginary parallelogram. The resultant of vector A and vector B, that is the sum of vector A and vector B, would be represented by the diagonal of this parallelogram in magnitude as well as in direction, with its tail at the point where the tail of vector A and vector B are coinciding. The parallelogram law of addition of vectors says that the magnitude of the resultant vector, that is R, is equals to square root of A square plus B square plus 2AB cos theta, where A is the magnitude of vector A, B is the magnitude of vector B, and theta is the angle between vector A and vector B. Since the resultant vector is a vector, so only describing its magnitude, only knowing its magnitude will not do the job. We have to tell that its direction exactly also. So let's say it is at an angle alpha with any of the vector. Let's say it is at an angle alpha with the vector A. Then the formula says that tan of alpha is equals to B sin theta upon A plus B cos theta. This is the formula. Using this formula, we can easily find the value of alpha, and once we have the value of alpha, we can tell at what angle exactly vector R is from vector A. We can take this angle also. Let's say we take this angle as beta, then tan beta would be equals to A sin theta upon b plus a cos theta. Okay. So once you know the magnitude and the value of alpha, you can easily find, or even beta, you can easily find at what angle vector r is. What is the exact direction of vector r? Even if you know alpha, you can easily tell what is beta, because beta is nothing but theta minus alpha, right? We know how to find vector a plus vector b. Now, if you are asked to find vector a minus vector b, then aren't you being asked to just add vector a and minus of vector b, right? Because plus minus will be minus, so it would be equals to vector a minus vector b. So subtraction is also a kind of addition, right? In the next part of this video, you will learn what happens when we multiply a vector with a scalar. But for the time being, let me tell you one thing. Let's say there is a vector a. Then a vector with exactly opposite direction and having the same magnitude is represented by minus of vector a. So if this is vector b, then this would be minus vector b. If you are asked to add vector a and vector b, you can simply do it by using triangle law or parallelogram law. If you are asked to subtract vector a and vector b, then if vector b is this, then minus vector b would have exactly opposite direction and same magnitude. That means the length of this arrow would be same as that of the length of this arrow, because the magnitude is same. So it would be minus vector b, and we can simply add vector a and minus vector b, because vector a minus vector b is nothing but vector a plus minus of vector b. Okay, now you can simply add vector a and minus of vector b using triangle law or parallelogram law. Let's say now if we apply parallelogram law, then what we will do, we will first complete the parallelogram, and this would represent vector a minus vector b, because we are doing nothing, just adding vector a and minus vector b, right? I hope you got it. Even subtraction is a kind of addition. When you are subtracting 3 from 2, you are just adding minus 3 in 2. Similarly, we can subtract two vectors using the triangle law of vector addition with the same logic. That is, the subtraction of two vectors is nothing but the addition of one vector with negative of the other vector. So, suppose vector a and vector b are two vectors. Then to add them together using the triangle law of vector addition, first we will ensure that the tail of one vector is coinciding with the head of other vector, which in this case we can clearly see that the tail of vector b is coinciding with the head of vector a at this point. So now we can add vector a and vector b together with triangle law of vector addition, and the law would give us this vector as the resultant vector. Clear? If I ask you what would, let's say this is vector r1. Now if I ask you what would be vector r2 representing vector a minus vector b, that is the subtraction of these two vectors, then we can simply write vector a minus vector b as the addition of vector a with negative of vector b. Since vector b is represented by this arrow, so minus vector b would be represented by an arrow in exactly opposite direction with the same magnitude as that of the magnitude of vector b. So minus of vector b would be represented by this arrow. Vector a plus vector b is nothing but the addition of vector a and minus of vector b, which would be represented by this arrow using the triangle law. So vector r2 is equals to vector a minus vector b. Let's solve a numerical problem. Two vectors of equal magnitude 5 units have an angle 60 degree between them. Find the magnitude of the sum of the vectors and the difference of the vectors. Let's first find the magnitude of the sum of vectors. Okay. There is a vector a, and there is another vector b at an angle of 60 degree from it. It is given in the question. Now, magnitude of vector a, that means a is equals to 5 units, and magnitude of vector b, that means b is also equals to 5 units. That means length of this arrow, magnitude of vector a is 5, and length of this arrow, magnitude of vector b is also 5. The angle between these two vectors is 60. Find the magnitude of the sum of the vectors. We know by using parallelogram law of vector addition, we know that we will first complete a parallelogram, right, like this, and the diagonal of this parallelogram will represent vector A plus vector B. Let's represent the resultant with vector R. Vector R would be equals to vector A plus vector B, and we know from parallelogram law of addition, magnitude of vector R, that means length of the arrow representing vector R, or the length of the diagonal, this diagonal, is equals to root under A square, which is 5 ka square, plus B square, which means again square of 5, plus 2 into A into B into cos of the angle between these two vectors, which is 60 degree. Okay, this will be equals to square root of 25 plus 25 plus 5 into 5, 25 multiplies by 2 gives 50 into cos 60. Cos 60 is 1 by 2, that is root under 75. This is the magnitude of the resultant vector, or you can say this is the length of the arrow representing the resultant vector, root under 75. We can write it in a better way, 25, 5, 5, 5, 1. So we can write it as 5 root 3 units. Right? Now, you are asked to find the difference of vector A and vector B. You are given that the angle between them is 60 degree. Vector A minus vector B is equals to what? This is our question. Actually, magnitude of vector A minus vector B is equals to what? Okay. So if vector B is this, then minus vector B would be this, an arrow with same length as of the arrow representing vector B, but exactly opposite direction. This is our minus vector B. Now what we will do, we will simply add them using parallelogram law. It looks a little rough, so just please don't mind. This would be this resultant vector, vector R, this is nothing but vector A minus vector B, because when we say vector A minus vector B, it simply means vector A plus minus vector B. We are adding vector A with minus vector B, and we will get vector R using parallelogram law of addition of vectors. So magnitude of vector R would be equals to square root of square of the magnitude of vector A, that is A square, plus, remember, the magnitude of vector B as well as that of the magnitude of minus vector B is same, that is 5 unit. Only the direction is changed. So plus B square plus 2AB cos 60, we will get square root of 25 square of 5 plus square of 5 again, that is 25, plus 2 into 5 into 5 into cos. If this angle is 60, this angle would be 180 minus 60, that is 120, because this makes a straight line. Okay, so if this angle, this part is 60, then this part would be 180 minus 60, that is 120. Cos of 120, that is square root of 50 plus 5 into 5, 25 multiplied by 2 gives 50. Cos of 120, that means cos 90 plus 30, that means minus sine 30, that means minus 1 upon 2. So this will give us root under 50 minus 25, that is root under 25, which is 5. So the length of this arrow representing vector A minus vector B is 5 units. This is our magnitude. Okay, so magnitude of vector A minus vector B is what? 5 units. This is our answer. Let us learn about what is component or resolution of a vector. Before we jump into this concept, it is very important for us to understand few things. Let's say there is a vector, vector A. There is a vector, vector A. Its length, that means the length of the arrow representing it, or in other words, the magnitude of vector A is, let's say it is 2 units. Okay. Then can you tell me what is 2 times of vector A? 2 times of vector A would be a vector which has the same direction as that of the direction of vector A, but magnitude twice that of the magnitude of vector A. So 2 times of vector A is this vector, which is directed along the same direction as that of vector A, but having magnitude 4 units, twice the magnitude of vector A. If I ask you what is 3 times of vector A, it is obvious 3 times of vector A would be a vector which has a magnitude 6 units. That means the length of the arrow is 6 units and having the direction same as that of the direction of vector A. This time the length of this arrow will be 6 units. So when you multiply a vector with a number, okay, which is positive, the direction of the resultant vector you get is same as that of the original vector, that is the direction of vector A, but magnitude gets multiplied by this scalar. So if we multiply vector A with 2, we will get another vector which has the same direction as that of the direction of vector A, but magnitude 2 times the direction of vector A. Similarly, we can find 4 vector A, 5 vector A, or 1.5 vector A, or anything else. Now, what happens if we multiply a vector with a negative number? Let's say there is a vector, vector A again. Can you tell me what is minus vector A? Minus vector A, that means we are multiplying vector A with minus 1. Minus vector A is nothing but minus 1 into vector A. That means a vector, the magnitude of which is same as that of the magnitude of vector A. That means the length of the arrow representing minus vector A will be same as that of the length of the arrow representing A. Okay, but its direction would be reversed because it is minus vector A. The negative sign only shows, the negative sign appearing in minus vector A only shows that its direction is opposite to that of the direction of vector A. If I ask you what is minus 2 vector A, it will be a vector the magnitude of which is 2 times the magnitude of vector A, and the negative sign is showing that its direction will be reversed. So its direction will be opposite of that of the direction of vector A. So this is minus 2 vector A. So if this is 2 unit, the length of this arrow is 2 unit, then the length of the arrow representing minus A will also be 2 unit because the magnitude of both vector A and minus vector A is same, 2 units. Now if we multiply it with minus 2 vector A, that means magnitude this time will be 4 unit, and the negative sign in minus 2 vector A is showing that the direction is reversed. What did we learn? We learned that if we multiply a vector with a scalar, a number, okay, what we get? We get another vector, the magnitude of which is mod lambda times of the magnitude of vector A. Okay, and the direction of the vector we get after multiplying, after doing multiplication, is same as that of the direction of vector A if lambda is a positive number, and opposite that of the direction of vector A if lambda is a negative number. Before we talk about component or resolution of a vector, let's understand what is unit vector. Unit vectors. How we deal with scalars? Can we write 4 as 1 plus 1 plus 1 plus 1? That is 4 times of the number 1? Of course we can. Can we write 5 as 1 plus 1 plus 1 plus 1 plus 1? That is 5 times the number 1? Of course we can. Can we write minus 3 as minus 1 plus minus 1 plus minus 1? That is 3 times the number minus 1? Again we can. We can deal with vectors exactly in the same way. Just keep in mind what is the role of the number 1 while dealing with scalars. 1 is, we can call 1 as unit, right? 1 unit. The same role is played by unit vectors while dealing with vector quantities. Let's understand how. Let's say there is a vector, vector A, and the magnitude of vector A is 3 units. That means the length of the arrow representing this vector is 3 units. Now, can we divide this vector into 3 vectors, each having a magnitude of 1 unit and direction same as that of the direction of vector A? So, if we do that, we can write it like this: the first vector with magnitude 1 unit, the second vector with magnitude 1 unit, and the third vector with magnitude 1 unit. Okay. Each of these 3 vectors has a magnitude of 1 unit and are directed along the same direction as that of the original vector, vector A. Okay, we can write them as a cap, and a cap. So a cap means unit vector A. We read it as unit vector A, and it means a vector which is directed along the same direction as that of the original vector, vector A, that each of these vectors are directed along the direction of vector A, but having a magnitude 1 unit. So if there is a vector, vector A, then A cap means a vector in the direction of the same vector, vector A, but having a magnitude of 1. So vector A, in this case, in this example, we can write vector A as 3 times of the unit vector A. Unit vector A, that is A cap plus A cap plus A cap, is 3 times A cap, which is vector A, right? Ultimately, adding these 3 together will give us vector A. Let's take another vector. Let's say it is A again, vector A. Can you tell me what is minus A cap? It is simple. A cap means a vector which has the same direction as that of the direction of vector A, but having magnitude 1 unit, right? 1 unit. The direction is same. We call it A cap. Minus A cap means a vector which is directed opposite to that of the direction of vector A, but having 1 unit as magnitude. The length of this arrow is 1 unit as well, right? It is just directed in the opposite direction of A cap, or of the direction of vector A. We have 3 spatial vectors to solve problems. These vectors are known as I cap, j cap, and k cap. We call them as the unit vector along x-axis, a unit vector along y-axis, and a unit vector along z-axis. Being more specific, it is a unit vector along positive x direction. It's a unit vector, j cap is a unit vector along positive y direction, and k cap is a unit vector along the positive z direction. Let's first draw, let me erase it. Let's first draw the coordinate system, coordinate axis. Y, x, let's say it is z. So now we have x, y, and z axis. Unit vector I means a unit vector along the positive x direction. Unit vector j means a unit vector along the positive y direction. And unit vector k means, or k cap means, a unit vector along the positive z direction. Okay, always keep it in mind. I cap, j cap, and k cap, because we will be using these unit vectors while solving numerical problems a lot of times.